Alright, so let's try to step into our first example to find the correlation coefficient here. Now, what I have here is two data sets. Right? What I have here is two data sets. And I call the top row here, which is the first data set, is to be the x values. And I call the bottom row here, which is the second data set, to be the y, okay? The y values. And so what I can see here, if you count the number of data sets, I can have 1, 2, 3, 4, 5, and 6, right? So n here, which is the total number of data sets, total number of data points is 6, right? And then of course, before you can proceed with anything, you do need to find out what the mean value for all the x are. So the mean value for all the x is going to be, according to my calculation. Now, you can always pause this video here and perform a mean value for all the x values yourself, okay? So according to my calculation, the mean value for the x values is 3.83. And likewise, the mean values, I also need to find the mean values for all the y values. And that is going to be 3, according to my calculation. And then the standard deviation for all the x values is 2.32. And then the standard deviation for all the y values is 1.41. Okay, those are my calculations. So once again, you can always pause the video and then verify my work here. Alright? And then, so there's n, which is 6. Okay? And now, the way how we start getting into finding our correlation coefficient here is n is 6, right? So to find the correlations, what I would do is I'm going to do 1 over 6 minus 1. Okay? And then I'm going to open a big square brackets here. And what I need to do is I'm going to go through the whole point of the formula here is that I'm going to go through each pair of data right here. So my first pair of data, I got 1 for x, right? And so that x value right there, I'm going to subtract the mean for x, which is 3.83. And I'm going to divide by 2.32. Right? And then still, with the first data set, even with the first data point in the set, right? I want to look at the y value, which is 2. 2 here is the y value for the first data point. And then I'm going to subtract the mean value for y, which is 3. And I'm going to divide it for the standard deviation for y, which is 1.41. Okay? And now, I'm going to have to look over to my second data point, which is that. My second data point here is going to have the x value is 2 again. I mean, just 2. But then minus 383, which is the mean for the x values, and divided by the standard deviation, 2.32. And then I'm going to look over to the y value, which is 1 and minus 3, divided by 1.41. Okay? And then I'm going to add that to the preceding values that I found, and then I'm going to add further. Now this time I'm going to start looking into my third data point, which is a 3 for x and a 3 for y. So I'm going to take on my 3 for the x minus the mean value for x, which is 3.83, and divided by 2.32. And I'm going to multiply that for the y value of the same data point, which is 3, minus the mean value, which is 3 again, and divided by 1.41. I'm going to keep adding, and then I'm going to add for I'm moving on to my fourth data point here, which has the x value to be 4, and then I'm going to minus 383 divided by 2.32. And once again, you can notice that this work here, don't ever expect that to be short. It can be long, okay? I mean, it should be long. Right here, divided by 1.41. Okay. 6 minus 3.83 2.32, 4 minus 3 divided by 1.41. Okay? So this is where I close my square brackets. And so now all you have to do is just do all the adding, subtracting, and then multiplying, okay? And then you add it all up together. And then remember, divide it by 5, right? All that here actually gives you a 5 there, okay? So according to my calculations, I would end up with an R, which is the correlation coefficient. In my calculation is a 0.85, or actually 0.86 if I round it up. So this value right here, 0.86, it's pretty close to 1 right here. It's pretty close to 1, right? It's a quite strong, right? Quite strong R, right? Close to 1. You know, that's some of the notice that we can see close to positive 1. Okay, so that's why, because it's so close, 0.86 is so close to positive 1. So what is our expectation here? The whole point of all this R right here is that I'm going to demonstrate later on with a graph. But then right now, as a way to explain to you, the expectation out of this correlation coefficient is that the data points, right? I mean, the correlation is positive. Okay, that's one expectation, and then, or you can think of that as it's going up. It's going up to the right. Okay, and that's how we find a correlation coefficient. And this is it's that simple. I do agree that it's long, but then it's just that simple. Okay.